Let us start to use R to manipulate data and inspect data. In order to do so, we have to understand what R variables are, how different types of data are stored as different data types within R, and how collections of data points are stored in data structures. The simplest thing we can do is use R as a calculator. For example, one may want to evaluate this expression and compute its value. To do this, let's insert a code chunk with the Insert Code Chunk menu here, or you could use the keyboard shortcuts, which are Option Command I on the Mac or Control Alt I on Windows. And now we can type out this expression. And you can see this is an arithmetic expression that uses these symbols plus, minus, asterisk, and caret, which stand for the operations of addition, subtraction, multiplication, the forward slash is division, and the caret is exponentiation. And the question then arises, which operators will be evaluated first? So, what will be the order in which they're evaluated? And that is determined by the operator precedence rules. Now, even though it's a fancy word, operator precedence basically follows the PEDMAS rules that we learned in elementary school, meaning that any parentheses, if there are any parentheses, they're evaluated first, and after that you have exponentiation, which is this caret sign, then D and M, which is division and multiplication, and the last two operations are addition and subtraction. So in this case, first 2 to the power 2 will be evaluated, so it'll be 4. Then division, so 8 divided by 4 is 2. Then multiplication, 5 times 2 is 10. Then addition and subtraction, so it'll be 1 plus 3, which is 4, minus 10, which means the answer should be negative 6. And we can test that by running this code chunk either through the run menu or with the keyboard shortcut Control Shift Return. And indeed, the answer is negative 6. Now, supposing we wanted to make sure that 3 and the subtraction between 3 and 5 is carried out first, then we must protect the subtraction operator with parentheses, since normally the multiplication operator, the asterisk, has precedence. And now what will happen is 3 minus 5 will be evaluated first because it's protected by parentheses. And so we will have negative 2 times 2 or negative 4. And therefore we will have 1 minus 4 or negative 3. So now if I run this code chunk with Control Shift Return, the answer should be negative 3. And that is indeed the case here. The answer is negative 3. Next, one could also evaluate expressions involving mathematical functions, such as this function with the exponentiation function. So let's try and do that. And we will insert a code chunk. And just like before, here we have addition and multiplication. Therefore, we must protect the addition with parentheses. So I will say 1.13 plus 0.334 times, which is the asterisk, 1, 2, 3, 4 functions predefined in R. So if I start typing the function exponential, it shows me a list, or I can see that list by typing tab, and then I can hit return to choose that function, and that's the predefined exponentiation function in R, and we'll say 0.9, and then we can go ahead and evaluate that chunk by Control Shift Return, and we get the answer. In this case, it happens to be 3.600859. R also provides predefined constants such as pi. Um, to see how to use them, let's insert a code chunk and evaluate this expression, which is sine of 23 pi over 2. And there's a predefined function called sine. As you can see, it showed me the list, it's there. And then we can tap out the rest of the expression. So 23 times. Now we need pi. It's a predefined constant, so you can, and which is just pi. You can do tab and see that it already is defined as a built-in constant. And I can hit return to choose it, divided by 2. And then I can run this code chunk, Control Shift Return, and the answer is -1. Finally, let's in terms of using R as a calculator, let's see how you can use scientific notation by computing the number of hydrogen atoms in 1 picogram of hydrogen gas. And that's going to be given by the Avogadro's constant, which is 6.023. Now, in scientific notation, we want to say times 10 to the power 23. And the way you depict 10 to the power something is with the exponent of the scientific notation. So you say E23. So that's Avogadro's constant times a picogram. And so that's going to be 10 to the power minus 12. And we can run this code chunk, and we will have 600 billion hydrogen atoms in a picogram of hydrogen gas. Now, we can use R not just as a calculator, but to do more complicated tasks. And one of the most important things that computers in general do, but R also does in particular, is to take in some input data, manipulate it in some way, and create output data. To do that, you don't just use it as a calculator, but you store data in the random access memory, or RAM, of the computer. And R and other programming languages provide a mechanism for us to remember and keep track of data that is stored in memory. Now, obviously, they have locations, addresses, which are numbers, but it's hard for humans to remember those addresses or numbers. And most programming languages, including R, provide what's known as a variable, which is a name that's associated with a memory location or a set of memory locations that store some data. And the way you can store some data in the random access memory for use later in calculations is by assigning some data to a variable. And the way you do that in R is with the assignment operator. So, for example, if you wanted to create a variable called X that stores the number of hydrogen atoms in a picogram of hydrogen gas that we computed above, we will use the assignment operator, which is the less than sign and hyphen. So this symbol is the assignment operator, and you can see this, it's sort of an arrow going left towards a variable. So you're saying you are storing the data on the right in the variable. And in this case, it would be Avogadro's constant times a picogram, which is 1e negative 12. And now, previously, when we ran those code chunks, um, um, when we were using R as a calculator, when there was no variable on the left or the assignment operator, it just echoed back the answer to us. But now, when we run the code chunk, you saw a little green flash appear, but R has not echoed the answer back because the answer of the computation, which is the number of atoms in a picogram of hydrogen gas, has now been stored in a memory location, and we will remember, and R will remember and track that memory location as a variable known as X. Now, there is an analogy between the variables of computers, which are names of memory locations, and the variables we use in math. And so sometimes people will use variable names like X, Y, Z, I, J, and so on to store their data. However, it's good programming practice to instead use descriptive variable names so that the name of the variable says something about what kind of data that variable stores. So, for instance, here, instead of storing the number of hydrogen atoms in a variable called x, it might be better to name the variable num hyd atoms. And um, variable names can be anything, and they can be as long as you want them to be, so long as they don't start with a number. They must start with a letter, but otherwise, they can be as long as you want them to be, and they can have any letters or numbers or symbols inside them. And um, this way of naming variables where your the first word is lowercase, so num is lowercase, and then the rest of the words have the first letter is capitalized. This is known as camel case because it sort of looks like a camel, is a good way to have descriptive variable names that are basically like phrases that have contained multiple words, making it easy for the variable to be descriptive of what data it stores. So I might say num hyd atoms and use the assignment operator to store the number of hydrogen atoms as before, and we can run this code chunk. And once again, it has stored this number. If we wanted to see what value the variable has, then we can just type. And the other thing to see here is that now that we have created this variable, R remembers it. So when I start typing out the name, R is already showing me the variables or functions that match the first couple of letters that I've typed, and I can use tab to complete it. Now when I run this code chunk, it will echo back because the second statement where I just type in the name of the variable and run it, it echoes back the value stored in that variable. Now, variables are not just going to occur on the left hand side of a statement, they can also be used on the right hand side. So it's not just numbers and data that appears on the right hand side. And that's one of the primary benefit of variables, which is that once you have stored data in them, then you can use them later on in other calculations. So you don't have to remember all this data, because you can store the data in some variable, in some memory location, and then reuse it later. And that's one of the main sort of powers of programming. To see a simple example, in this computation of computing the number of hydrogen atoms, we could have stored mass of the hydrogen gas, in this case a picogram, in a variable called mass, and then we can store the Avogadro's constant in a variable called avo, and then to compute the num-hyd atoms, we can say the number of hydrogen atoms is mass times the Avogadro constant. And um, we can add a statement to echo back the value of the number of hydrogen atoms and run this code chunk. And now we have stored data in two variables, two memory locations called mass and avo, that we can use over and over again in subsequent calculations.